Thank you very much for the opportunity here today to present our new concept for a robotic gripper. This gripper is called Caesar, the Seeing Tweezers. My name is Cornelius Niemeyer. I'm the head of the automation business area at the company called Brütsch Elektronik. Brütsch Elektronik is a Swiss SME. We are about 160 people based close to Schaffhausen. And we are active in two areas. One is industrial automation and the other one is medical technologies. This project came to be with the Biromed lab at the University of Basel, headed by Professor Georg Rieter, and in collaboration with his team, especially Cédric Duvenet. Now, where do we come from? At Brütsch Elektronik, we are a provider of turnkey solutions for the Swiss manufacturing industry, special machinery for automated tasks, but also we are an engineering partner for Swiss machinery OEMs. And when you're looking at practical automation implementations in industry, there are various practical challenges, especially when you're looking at automating something with very delicate parts, often small parts. You have several challenges that I've listed here. This could be, for example, an assembly task of involving small delicate electronics or small optical parts or small mechanical parts, like watch parts, for example. And you typically have, first of all, the problem of the precise and secure handling of the object. So you want to grip it, grasp it, move it somewhere, place it somewhere, stick it into something without destroying it. What you typically then do is that you use vision as a technology to control your process. However, that often leads to loss of cycle time. So you have an object, you have grasped it, then you hold it into a camera as a separate automated step to analyze how the orientation of the object is. That loses time. And last but not least, when you have these delicate objects, then the gripper is very important that it really fits nicely and well to the object that you want to grasp. Therefore, typically generic grippers get you only so far but are not the optimum. On the other hand, customization is often quite expensive. So you might have guessed it, for these challenges we now have a solution. What we did was we combined with the gripping task some technology that we have at Brütsch Elektronik and that we know very well. And this is tiny camera technology. So what we have done is we integrated a miniature camera into a gripper to make it a seeing gripper. I'm showing you now a video to show you this. So here we have a light source and a tiny camera integrated at the center in between the fingers of the gripper concept. On the left you see the image that you are looking through the camera. So that helps you to monitor the parts within the process. So how have you gripped it? Is it rightly gripped? How is it oriented? You see it's not symmetrical, the part. So you can, inside the process, look how it's oriented and put it somewhere, assemble it into something, how you want to do it. And the fingers of the gripper are easily customizable. It's 3D printed. You can do configurations with 2 fingers, like a tweezer, 3 fingers, 4 fingers. The fingertips can be adapted. And it's easy to, there's a very easy, elegant mechanism to couple and decouple it. So you can really specifically design the grippers to what you want to do. So last but not least, you want to ensure that you handle your object securely, that you don't squish it, for example. So what we do there is that we use this miniature camera as an optical force sensor to understand the gripping forces at the fingertips. The fingers of the gripper are designed in a flexible way. So tracking this deformation of the finger in an optical way enables us to calculate the gripping forces. So in summary, we have now combined 3 quite new ideas into a radically new concept of a gripper to really safely deal with, and in an efficient way, deal with delicate parts as well as small parts. So it's suitable for a broad range of applications. You can actually see this in action. We have here on the gallery, roundabout in the middle, the booth of the Pyramid Lab of the University of Basel, where we have the demonstrator of the Caesar, and you can have a look at it. We are very much interested in getting in touch with you. Just come by, talk to us. We are interested in lots of things. 3 things I want to mention here. One, of course, we are interested in possibly your application case, your use case for this technology. Second, we are very open to companies who want to maybe partner with us to further commercialize this technology. And last but not least, seeing the audience here, we're always looking for great people. Right? So if you want to work on interesting real-world automation problems involving cool ideas such as this, just come talk to us. Thank you very much.
Thank you very much, Cornelius. And I think it's very good that you finished by talking about partnership. It's very important that we want to emphasize the fact that Innovation Booster Robotics and the projects that are financed by the Innovation Booster Robotics are about partnerships between an academic partner and an industry or a CME, a startup. All the time, all the projects are about partnerships. So thank you for saying that.
Yes, and this really, for us as a SME in Switzerland, it's really important to have the possibility to do funding such as this, such as the Innovation Booster. And it was a great experience to partner with the University of Basel here. So I can really recommend it if you have some ideas to do such kind of projects.
Thank you very much.
Thank you.